This is lesson 4.2, covalent bonding. A covalent bond is the electrostatic attraction between a pair of electrons and positively charged nuclei. So remember, this is between two nonmetals, and it's the sharing of electrons. And we call atoms that are held together by covalent bonds molecules. Non-bonding or lone pairs are electrons that are not involved in forming the bond. So a diatomic molecule has 2 atoms, triatomic has 3, and so on. Atoms often must share more than one pair of electrons to achieve their octet, and this is when multiple bonds are formed. A double bond is when 2 pairs of electrons are shared, and a triple bond is when 3 pairs are shared. There are multiple steps to drawing Lewis structures. The first step is to calculate the total number of valence electrons in the molecule, adding 1 electron for each negative charge and subtracting 1 electron for each positive charge. The second step is to draw the skeletal structure of the molecule and put the atom that wants the most bonds in the middle. The third step is to connect all of the atoms together with single lines to show 1 electron pair, and this bonds all of the atoms to the central atom. Next, add more electron pairs to complete the octet. Step 5, if there are not enough electrons to complete the octets, you must consider multiple bonds. And last, check that the total number of electrons in your structure is equal to that you calculated in step 1. The formal charge is a way to check your Lewis dot diagram. So the formal charge on an atom is equal to the number of valence electrons for that element minus the number of bonds minus the number of unshared electrons. And the sum of the formal charges must equal the overall charge on the molecular ion. So when you have a Lewis structure that you're not quite sure which one is correct, you pick the Lewis structure where the atoms have formal charges closest to 0 and the negative charges are on the more electronegative atoms. There are exceptions to the octet rule. The first exception is when you have incomplete octets, for example in beryllium chloride or boron trichloride. This usually occurs when you have small central atoms because they don't have enough room to fit 8 electrons around them. An expanded octet occurs if you have large central atoms that can have more than 8 electrons around them, for example in sulfur hexafluoride. A dative or coordinate bond is formed when both electrons that are being shared come from the same atom, and sometimes arrows are used to show dative bonds. So an example would be in ozone, O3. So these 2 oxygens are each sharing 2 electrons to form a double bond. But you can see these 2 oxygens, both electrons that are being shared are blue, coming from the central oxygen. So this right here is a dative bond. The bond strength is related to the bond length, or the distance between 2 nuclei. The bond strength is a measure of the energy that's required to break a bond. And the shorter the bond, the stronger the bond. So triple bonds are stronger than double bonds, which are stronger than single bonds. Remember that polar bonds result from unequal sharing of electrons because one atom is more electronegative than the other. We call this a dipole when polar bonds have 2 opposite electric charges. So one end is partially negative and one end of the bond is partially positive. And remember that you can determine what type of bond you have by subtracting the electronegativity values for the atoms. So if you subtract the electronegativity values and there's almost no difference in electronegativity, you have a nonpolar covalent bond. If you subtract the electronegativity values and they differ up to about 1.8 units, you have a polar bond. And if it differs by more than 1.8 units, you have an ionic bond.